Hi, good afternoon, good morning. This is Mariano Ortega de Mues. I'm the CTO of Edge Computing and IoT, Internet of Things at Minsight in our company. And well, during this session, I will introduce to you in the amazing world of Edge Computing, trying to provide you with a brief introduction of what is Edge Computing, but bringing into what is edge computing, first of all, throughout IoT. That is to say, we are moving from IoT to edge computing, and later we will review the different current technological enablers that are helping us to implement edge computing architectures and the different use cases, the amazing use cases that we can provide to our customers using this kind of technologies. Um, a good way to understand, to explain or to describe this presentation, it's edge computing in a nutshell. Just 50 minutes talking about edge computing. Okay. Well, well, now you can see the index. First of all, we will see what is IoT. Later on, I'm talking about IoT also for understanding the use cases that IoT deploy and and promote in the technological scope in our users, in our customers, the problems that the IoT platform currently have, and how those problems can be solved using edge computing. Okay, well, let's go with the beginning. Well, and at the beginning was internet, and this is not a joke. Okay, I think that all of us we are really used with this historical evolution, the evolution of the distributed systems around internet. Okay, in this diagram, you can see the evolution of all these distributed systems, starting at the PC area, mm, and to the current stage of the web, of the internet, focusing in web 4.0, and the edge computing, the digital twins, and all the intelligent agents that are connected to the internet. Okay, let's go to review briefly the different steps in this evolution, starting with web 1.0. Okay, um, internet at the beginning in web 1.0 put together people, okay, physical people, producers produce different websites, and other people, physical people, consume those websites. It's the history, and we will really know very well this use of internet, which is the web, the real web. Okay, web, the 3W was the first minimum value product in the new distribute ecosystem of internet. Okay, web 1.0 connect people, producers, and consumers of information, and this was the first community and the first interchange of information between different elements connected by one service. Okay, after web 1.0 became the next step was the rise of social machines. And in social machines, physical persons became digital persons or users or profiles connected to the platform, connected to the internet and to the web, and but playing at the same time the role of producer and consumers. Okay, people in this is the time of the first RIC uh, RIA applications like Facebook or Instagram or YouTube. People not only produce websites, HTML, but also produce photographs, videos, okay, and put all this information inside the internet, okay. So the community became larger, very larger, okay. But even at that time, internet was used to connect people, and the community was around, and the social machine were around people, okay, people and humans, okay. This is why these two phases of web are oriented to human technologies, human-oriented technologies. That is to say, all the formats, all the information is exchanged using those social machines and using internet. The main focus was is that this information was developed to be consumed by humans. Okay, so at the beginning was internet for putting together people, at least in the two first steps of internet and these and internet communities and distributed systems. Mainly humans were connected and interchange information for the consumer produce and consumed by humans. Okay. In internet in web 3.0, together with those humans, with those prosumers producing energy, producing different informational resources, okay, to be consumed by other humans, a new element connect with those communities, the machine themselves, okay, big IoT systems or sensors or actuators or even agents was the rise of the IoT, Internet of Things, and in this moment there was an important change in internet because all the technologies change, all the technologies and the way we produce information and we model reality and we model information change from being only human-oriented technologies to human and machine-oriented technologies. This is this time from 2010 to 2020 more or less, okay, all the different agents, artificial agents, connect with us and start interacting with the prosumers, okay. This is why at the beginning was internet for connecting people, then materialize, okay, and it marks the start of IoT, Internet of Things. But what is really Internet of Things? Internet of Things, well, the concept of Internet of Things back in time was first mentioned in 1999 during a speech at the Davos Economic Conference by Bill Joy. Bill Joy was one of the Stanford University Network or microsystems, some microsystems. Okay, at that conference, someone asked a request from Bill, provide a dissertation of the different communities that will arise in the near future regarding around the internet technologies. And he envisioned at that time that the last level, the web type 6, and at this web level 6 was the internet of device to device, an internet full of sensors deployed and in message networks, okay, and with embedded artificial intelligence inside in ordinary things, okay, Remember that this is a description in 1999. Okay, currently we are living this reality. Okay, our washing machines can connect with internet and talk with the manufacturer and provide information regarding the maintenance. Okay, or they have some problems. Okay, and the manufacturer send us information, send us an email or even a contact with us in with WhatsApp, saying that hey, probably you will have a problem with your laundry machine. Okay, remember, Bill Joy was a great visionary, and this is the first mention of Internet of the Things. Okay, but you have realized was not the concept was not Internet of Things, was the concept of device to device. Okay, the real one person with introduced the Internet of the Things concept was Kevin Aston. In the same year, in 1999, in a presentation delivered at the Meet Auto ID Center. Okay, remember that at that time, uh, um, uh, um, in a identify the different resources in the world from a unique point of view was a tricky question, and Kevin was working on the Auto ID Center on the RFID technologies, okay, in order to identify with tags the different objects in the world. Okay, well, the paper or the presentation he delivered was titled "That Internet of Things." In the real world, things matter more than ideas. Kevin focused in this paper on a tricky question was that at that time most of the information stored in internet due to the human communities was information gathered using our fingers, okay, introduced into the internet, into the web, into the distributed systems by humans, and most of the information was related with uh, papers, photographs, books, libraries, knowledge and concepts. Okay, but few information uh, refer to the world. Okay, and if mm, Kevin Aston thought that at that time, if we want to use machines to improve sustainability, improve the way we produce, really use all the power that machine can provide us, we need provide to machine the capability, but we need power computers with their own means of gathering information. That is to say, provide to computers the capabilities to see, hear, smell the world, the reality for themselves. Okay, and also apply to this information um, the new machine oriented algorithms or machine oriented artificial intelligence, okay, in order to understand the world without the limitation of human enter data. Okay, this is exactly the goal of Internet of Things. Okay, put together in the same community, people talking with people, people talking to machines, and providing to machines the capability to sense the world. Okay, get information from the world, analyze this information, and provide us and our processes and the way we live, the way we produce new products, the way we deal with the problems in the reality, with new insights and a new way to understand reality. Okay. Currently, well, this was in 1999. Currently, an IoT enterprise system is a network of IT systems that can enable a company for interacting proactively with its environment, trying to understand environment in a really wide meaning. Okay. And thanks to this, companies can improve its operational efficiency and provide new services and products to the market. Okay? This is why an IoT enterprise system should provide to a company or to a government, a public administration, to the owner of the infrastructure, the capabilities to sense the world, sense the world, meaning understanding what is happening with the machines that the company use to produce something in their plants, for example, or is the company is a power utility, sends get information from the different smart grid infrastructure. Okay, or if the owner of the infrastructure is a government, for example, or a mayor in a city, get information from the traffic lights, or get information from the traffic control systems. Okay, or even getting information from the waste that is in the street, or the people walking in the different streets. Sense reality, communicate this information, this sensing, to different distribute elements of analysis and decision. Okay, and later act on the reality and perform some changes in this environment. Okay, this is what an IoT system is. Okay, and all these all these four different capabilities powered by machine agency. Okay, trying to realize this idea, the first IoT cloud architecture were mainly focused on cloud. Okay, and the idea was deploy sensors and actuators around the world or around my facilities, in different elements in your even in your home, like or your fridge or laundry machine or whatever, or put sensor in your vehicles. Okay, and get this information and put all this information, this huge amount of information, send this huge amount of information to the cloud. Okay, and process and analyze all this information in the cloud. Here you can see that in this kind of architecture, there's only one step between the IoT level, the reality, the analogic wall, the sensed analogic wall with the IoT level and the cloud level. Only one step. Okay. Among sensors, in this first wave for IoT, it was also quite common to deploy actuators. Okay, and also some control was performed in order to open a pumping station, for example, or in a river, or in a river basin, or actuate over other really simple elements. Okay, probably 60% of the all the analysis was performed in the cloud. Okay, having in mind that thinking that cloud was the single virtual place to analyze information and take decisions. Okay, typical use cases that at that time, in the first century, in the first years of our century, that apply these kind of technologies were smart parking. Okay, for getting real-time information regarding the parking, the billing and the traffic management. Also, the fitness device that we wear. Okay, that provide information related with the customer, getting this information you wear the band, get your healthcare conditions, and send this information throughout your mobile to an IoT platform where analyze this information, and and then providing some feedback to the prosumer using an Android application or iOS application. Okay. Also, that in this time, logistic, all the use cases related with the logistic and the tracking of goods was one of the key use cases in this time. Okay, and with this kind of IoT cloud architecture, for sure, environmental monitoring, putting sensors all around the world and monitoring the air quality in cities, for example, or the water quality in a river or in a dump, in order to analyze the quality of the water. Also, perform fire detection in woods and in forest, and also analyze, for example, the snow conditions. Okay. Um, Very important use cases in this period of time was the use of IoT cloud architecture, um, done by the utilities, getting all the information from the smart meters, for example. All the meters get the information. In the case of energy meters, for example, get all the information, all the information regarding how you are using energy. Okay, when you consume energy, and send this information to the cloud, and in the cloud perform the profile of your use of the energy. Okay, in order to finally provide to you with offers and a new offering regarding how to optimize the use of the energy in your home, for example. Okay. Other successful use case for IoT cloud architecture was a smart home. Okay. A smart home, combining devices with Wi-Fi or other radio frequency technologies connected with a gateway, and this gateway getting all the information coming from the sensor in your home, and helping you on establishing the air conditioning or preventing someone getting into your home. Okay. Smart architecture was also one of the key use cases at that time, using IoT cloud architectures. Okay, but IoT cloud architecture um, have different problems or different constraints. Okay, the first one, which is obvious, is what happens if there's no communication. Okay, if we go back to the general schema previously showed, if we don't have communication between the sensor and actuators in the field with the cloud, we cannot act and we cannot sense the reality, so nothing will works. Okay, so all the use cases supported by IoT cloud architecture were mainly focused on monitoring, on getting information, but few of them were really able to provide control and advanced use cases, all those advanced use cases that we want to have today. Okay. Together with this problem of what happens if there's no communication at all. Okay. It's really common to mention two big limitations of these IoT architectures. The first one was latency and decision time. Uh, one of the reasons why edge computing is really needed, it's because if we need to take decisions regarding if if I have a problem in my car and I'm moving 120 kilometers per hour, okay, these decisions should be taken really, really fast. Okay, and it's not it may no sense to send this information to the cloud and analyze the information in the cloud and send a command to my car in order to prevent an accident, for example. Okay, there are many use cases that really matters and are key for the digital society, that implies um, um, a high requirement regarding decision time and latency. Okay, here in the picture you can see some of them. For autonomous driving, most of the decisions should be taken in less than 1 millisecond. Okay, quite similar to an augmented reality and virtual reality. Okay, in order to enable system for disaster alert. Okay, the mean time for decision is in most of the situations is no more than 10 milliseconds. Okay, in real time for real time gaming, you need to take decisions or to plan the new movement or whatever in less than 10 milliseconds as well. Okay, for bidirectional device remote controlling, that is to say, for controlling a device in a plant, in a device in charge of the production of cans, for example, or bottles. Okay, you all the decisions should be taken in less than 100 milliseconds. Video streaming, in order to analyze video streaming, for example, or in order to interact with the user through our wearables, the main decision should be taken in less than 1 second. Okay, so the IoT cloud center architecture are not capable, are not able to handle these use cases, and are really important. Why? Because we can use algorithms in order to analyze these situations and to take decision, thanks to machines that improve our experience or our processes. But in order to take those decisions, we cannot send this information to the cloud, because sending information to the cloud always takes times, whatever this cloud is. Okay. The other big limitation for this kind of architecture was the cost and the security. Okay. Really made no sense to send all the information, all the raw information that you acquire from Samsung to a central cloud. Okay, you will send a tsunami of information, and sending this information really cost have a has a high cost. Okay, why? Because even if we have a big bandwidth, even if we have 5G, every all the telco market is based on the scarcity of the bandwidth itself. Okay, and any market of scarcity is produce cost. Okay, so may no sense send all the information to the cloud. Probably most of this information provide you is not value for you, produce no value. Okay, it's just information that you get due to the architecture you are using. Okay, a little more. Sending all the information from the sensors or from the machines you are sensing, or the elements in the real world you are sensing. It's a tricky question for security. Okay, remember that we are living in a time in which the company who has the raw data can take this raw data, use this raw data to train and machine learning algorithm, and probably perform the similar process that your business performs, probably in a better way. Okay, so really makes sense to keep the raw information where this information is produced and analyzed, and use this information really close to the machine or the person or the system that produce this information, not sending and moving this information. Analyze the information and share with others, with other systems, the aggregation of this information, of the decision that you have already, of the insight that you have discovered on the information, instead of the raw information. This is why edge architectures arise. Okay, edge computing. What is edge computing? Edge computing is a distributed topology with information processing is placed closer to the thing, to the equipment, or to the wearable, uh, uh, to the thing, or to the wearable, processing the information close to the thing or the people that produce and consume the information for a fast delivery. Instead of having just one instead of having just only one step between the devices in the field, and the cloud infrastructure, divide this chain in different steps. Okay, and also divide the analysis and the decisions that you take based on this information in different levels. Okay, um, with this kind of information, with the kind of architecture, the two problems that we have seen before vanish. Okay, why? Because all the decisions regarding your autonomous vehicle, for example, all those decisions, all those algorithms are performed in the vehicle itself. Okay, and this vehicle can work even without communications. Okay, and providing and executing the decisions in a really fast way. Okay, this is why edge computing it's a solution. It's a complement of all IoT architectures. Okay, there are many methodologies for describing edge computing. The different levels that indeed exist in this chain between the sensor in the field and the cloud. Okay, and it depends on the community behind the methodology, or the work companies or the consortium behind the methodology. For you to know, because it's important to mention, which is the one of these methodology is the multi-access edge computing, which is the one promoted by the telco environment. Okay, but there are others. Okay, like the Open Fog Consortium, which is the methodology uh, for dividing for dividing the for dividing the edge computing chain, thanks to the Open for Consortium and the industrial IoT consortium. Okay, in this kind of architecture, most of the computation is performed in the device itself and few in the cloud. Okay, okay. Trying to provide you with a general overview of how the modern edge computing architecture are being organized. Okay, you can have a look to the European Cloud to Edge Technology Investment Roadmap. Okay, in this type of architecture, there are different layers, different tiers. Okay, coming from the cloud to the different device in the field. Okay, and these different tiers are divided, having in mind the distance to the final user. Okay, the distance to the final user. Here you have you can see that the first tier, that it's called on premise. It's with a distance few of 1 kilometer from the user, and here you can have 100,000 of nodes. Okay, and all of them connected, and in those nodes, living a lot of devices. For example, in a home, living all the devices that you have in your appliance. Probably also some virtual reality glasses. Okay, for playing or for gaming or for interacting with something. Probably also for learning. Okay, and in a stadium, where people with a phone can be talking with each other, or saying the streaming coming from different cameras. Okay, or plants, where people with the same with the previous professional glasses seeing the infrastructure and looking at the machines and getting the technical information from the machines. Okay, this is the on-prem division, the first division in this the chain, uh, coming from the IoT part to the cloud. Okay, the second one, it's the far edge. When you probably you will deploy artificial more demanding algorithms, okay, for processing the information coming, for example, from the stadium. Okay, and you can here in this far edge, you can produce the video stream, and reach the video stream, perform artificial intelligence for analyze the different the different the play, for example, and analyze the position of the players in a basketball match, for example. Okay, later on, the near edge, and it's called near edge because it's quite close to the cloud, to the cloud, which are the big data processing centers for processing data. Okay, well, those are the this is one of the possible divisions of the edge computing continuum. And well, here you have the typical distance, and also the typical number of nodes that we hope to have in the future connected all around us. Okay, on-prem, 100,000, and in the far edge, from 100, 1,000 to 100. Few big data centers all around the country. Okay, and later on, all the countries connected with central data centers for connecting all this infrastructure on all these services with hyperscalators. Okay, around edge computing, there are many different manufacturers coming from. So the ecosystem is extremely complex. Okay, and here there's a lot of providers and want to play an important role. Okay, general cloud providers that coming from the cloud can provide the application that finally are deployed inside the edge computing close to the machine itself. Okay, or close to the field. Okay, to also general hardware providers that won't provide the big and from big, medium, and small machines for implementing all the computation that should be executed in the different tiers. Okay, telco hardware providers for providing communication, the best type of communication in the between the different tiers. Okay, probably 5G in the 5G from the far edge to the on-prem, and connecting many different small devices in the different areas. Okay, and deploying in the far edge all the infrastructure needed, not only for the radio access network. Okay, but also for the applications analyzing the information coming from those devices connected with 5G. Okay, and using a small bandwidth for small devices, but also using big bandwidth, gigabytes bandwidth for analyzing, for example, the stream coming from a stadium, or the information, the vibration information coming from a machine in a plant, or on a turbine in a dam, for example, and sampling the torque of the turbine, or the vibration of the temperature of this turbine, um, in a high frequency, for analyzing this information in real time and identify if there's some problem with the turbine itself. Okay, well, general platform providers, general hardware providers, telco companies, and on the other hand, Um, the traditional industrial hardware providers really close to the brownfield. That is to say, to how up-to-date automation has been taking place in different industry and the different scenario that we use it. Also, specialized cloud providers focus, for example, in analyze the way we use this big technical device like a turbine that I mentioned before. Okay, all those mix of all this complex ecosystem can be summarized with the previous schema, understanding that in order to connect all the devices in the field with the applications and enable distribute intelligence from the cloud to the different tiers at the edge, there are at least two different ways to go to the business. The first one is the role playing by the telco operators and the cloud providers. Okay, that try to apply the cloud technologies, applications and systems to the edge. Okay, bringing applications with virtualization techniques like containers and so on. Okay, from the other, we are used to talk these players that perform the cloud to edge transformation. Okay, and on the other hand, the private edge providers coming from the automation from coming from the brownfield and from the automation ecosystem. We usually call these private edge providers that they move from edge to the cloud. Okay, both of them have strengths and also weakness. Okay, for the manufacturer coming to the edge to the cloud, pues they know they are experts in the brownfield automation, but they most of the cases they have few knowledge on workload consolidation and IT governance, on how to deal with the application that you deploy in the different tiers in the edge part. Okay, in the other side, telco operators and normal cloud providers, well, although they have a strong knowledge on application distribution of workloads and how to create the applications following the cloud native foundations norms. Okay, they are really weakness on the real use cases of technology. Why? Because they have poor knowledge on the real deployment environments and operational conditions that should take in account when you deploy applications in a farm, in a industry, or in a stadium, or or for managing a building. Okay. Anyway, as both things are trying to connect, currently we talk about cloud to edge continuum, and in the near future, both all the applications running in the cloud and all the applications running at the edge will converge. Okay, and just the same way applications are created and deployed in the cloud, in the near future will be possible to deploy those applications just in the same way and using the same techniques in the edge. Okay, this provide a lot of benefits. For example, in the reduce the time to market for providing new services. Okay, currently trying to understand how to distribute the computing among the different tiers that we have seen. Sorry, that we have seen. Um, um, there are different techniques in order to move the workloads among the different tiers in the edge computing. Most of them are based on virtual machines and containers, and also the execution of room times, specific room times, are good trends to coordinate and to adapt the to deploy the applications and to the and to um, and to manage and to govern all this infrastructure. Okay, we have here I have two different examples on how to deal with this. Okay, for example, in the case of AWS, the platform for dealing with edge computing in the AWS ecosystem name is Greengrass. Okay, and connect the cloud with with the Greengrass core, which is an environment for running functions and for connecting with devices in the different infrastructures where you deploy Greengrass. Okay, you set up a Greengrass group around a Greengrass core and connect all the different devices to this Greengrass core and send information and accept the commands that finally are sent to the different devices. And also you can perform different analysis calculation in order to obtain insights regarding the information that you have acquired or the situation or the yes or the context and the situation of the different devices you are managing. Okay, in the case of all the manufacturers that provide you with a powerful edge and device IoT edge device is Microsoft Azure with Azure IoT Edge. And in this case, where you manage, obviously you have an IoT hub, a central element from where you manage all the different devices that you have in the field, in the different tiers, and also the different applications already deployed in those machines. Okay, and the way for moving those applications is using containers, an agent and containers. Okay. Finally, and another good example is VMware Tanzu. With VMware Tanzu, you are able to distribute among your infrastructure in the different tiers virtual machines using the traditional hypervisor from VMware, but also containers, and also you are able to deploy Kubernetes clusters, and coordinate all of these technical assets using agents. But if you need to think in the future, the Kubernetes is for sure the standard for behind these kind of platforms in order to orchestrate the different workloads running in the different tiers. Okay. Well, we have seen IoT. We have seen its architectures, the technology behind the edge architectures. We have seen the different tiers in a edge architecture and why a architecture important. Okay, with current technical enablers out there that are pushing this kind of architecture. First of all, and if you remember what an IoT platform is, currently we have regarding sense the world and act they are, currently we are living currently we have a sensor for almost all the critical areas that you can imagine. Okay, we have sensor for accelerometers, for acoustics, for pressure, humidity, proximity. There are few um, there are few important processes, the important physical processes that currently you cannot measure or you cannot digitalize, okay, and get this information. Okay. Also, these sensor platforms can be combined in new form platform for equipment. Okay, and this equipment can be instead of big machines or computing machines in a rack, for example. The machines are currently there are many form factors in order to put those machines in almost anywhere where you need to deploy the machines. Okay, and finally, there's new hardware platforms like drones, robots, wearables. um, uh, be aware, augmented reality glasses, helmets. Here are, in this case, for example, this is the case of Dakri helmet. Okay, this is a great helm because inside the helm you have also a thermal camera. Okay, and this one not only can apply augmented reality, but also can measure temperature. Okay, and identify if an equipment has some problem. Just just looking at the device. Okay, and sending this processing this information in the helmet itself, or sending this information to another edge computer or edge node, and analyze the image in this server. Okay. Or well, this helmet is interesting. Other example, and this is an example from British Gas. Okay, in order to prevent problems with the techniques. Okay, for people in the field installing pipes. Okay, but this is a gadget that you can wear, covering your kidney. Okay, and measure every time the time you are in the ground, manipulating different pipes, and sending you information for a move. Probably if you remain in this position, you will find you will have problems with your kidney. Okay. Mm, Send and act, communicate. Currently, there are a lot of type of communicate. The landscape of possible communications is extremely wide. Okay, and in order to understand what kind of communication you should use in deploying your edge or your edge computer architecture, you need to understand the range of communication that you should cover with all your devices. For personal area networks, really close, less than 100 meters, to huge distance. Okay, more than 10 kilometers. And also, if the devices you are going to all the IoT or edge devices you are going to put in the field, um, are supported by batteries. Okay, so you need to reduce the consumption of those devices, and also the communications demand regarding with the batteries. And if you don't have this constraint, the battery constraint, you can move to Wi-Fi communications, or to WAN communications, coming from 2G to 5G, and all the catalog of communications that you can find, on the different category of communications that you can find in 4G. Okay, in order to send, communicate information, so analyze. Okay, we are living a tremendous effort for all the manufacturers, chip manufacturers, for providing with chips with GPUs, PGIs, CPUs, or visual processing unit, or tensor processing units, specialized in apply artificial intelligence in all the different tiers in the edge computing. Okay, for example, bringing object detection, or segmentation, or tracking, to small devices in the far edge, and prevent sending the stream to the cloud, and analyzing the information close to where the image is produced. Okay, here you can see logos from the main manufacturers for the different technologies. For CPUs, obviously ARM. It's a key hardware architecture. Really focus on a low consumption, because ARM is the main architecture deploying in mobile phones, for example. But also you have Intel, that is one is the key architecture deploying the data center or regarding the 5G, for example. Okay, so we have sense a lot of type of sensors. We have a lot of type of communications for communicate the different tiers of the edge. We have a lot of hardware capabilities to apply artificial intelligence and data science in general in the different tiers. Okay, and you can those are the main enablers that you can find in the market in order to configure your IoT edge architecture. Okay. Regarding use cases where edge computing creates or enable a lot of use cases. Okay, here you can see the main use cases that will be enabled by 5G, for example. Okay, and in this case, having in mind the bandwidth that you will need to use in order to perform your use cases, and the delay that you can assume in order to deliver those use cases. Okay, these capabilities, for example, sending more than 10 gigabits per second and perform having a delay of just 1 millisecond enables the autonomous driving. Okay, so and autonomous vehicles. Okay, where devices talk each other. Okay, in the close in talks each other near in the far edge, and also send information to the cloud to provide information on how, not only where the car is, but also if there's some problems with the engine, for example. Okay. Other use cases for real-time stream analytic at the edge, for example, if you currently most of the connected car manufacturers inside the car, you will find embedded edge computing. Okay, and inside this edge computing, there's a lot of artificial intelligent algorithms and getting information from all the different cameras in your car. Okay, and analyzing the traffic, or if you are in the line, or analyzing the different signatures in the street, for example. Okay, where we're in the road. The retain is also an important market that is using edge computing. Okay, and the retail to improve the user journey in the different shops. Okay, every time you go to a totem, okay, with a camera and with a screen, and you search for information, probably inside this totem there's a camera getting your face, getting information about you, scanning with Wi-Fi if your telephone is on, if your communication in your telephone is on, getting information about about your mobile using Bluetooth, all for providing you a best experience Yeah, I'm all right again. Okay. Oh well, Jonah, thank you very much for your suggestion. Today I'm not going to talk about meta. Okay. Well, later on I will say something about that. Okay. But it's confident currently is focusing what I'm trying to explain today. Okay. Dealing with uh, put together physical world with digital world. Okay, in what is currently is would call it's called physical. Okay, this combination. Okay, um, um, in virtual reality like Meta, for sure, you can experiment with things. Okay, you can provide a retail experience, an advanced retail experience. Okay, but what retail experience is just one of the use cases of edge computing, and IoT and edge computing try to provide machines with how to sense reality, know how to put people in a different virtual reality. Okay, and trying to achieve goals like sustainability. Okay, the approach of providing to the customer a virtual environment is radically different from applying edge technologies for bringing a new experience to the physical real customer in a shop. Okay, for example, as the use case that you mentioned. Okay. Well, here I have here I have as an example of this kind of new devices that this kind of new edge platforms have bring with me smart Wi-Fi detection, which is one of our products. This in this product we put this product in the top, the pillars in the transmission lines in the power utilities. Okay, before this kind of products that it's produce it's computing. Before this kind of products in the pillars, we provision normal cameras, sending the stream to a cloud and analyze the information in the cloud. Okay, with an extremely highly cost for power utilities. Okay, thanks to this kind of devices using edge computing and in this case uh, Intel technology for dealing with artificial intelligence, we are able to analyze all the information coming from the surrounding of the pillar and prevent things like fire in the boots. I will reproduce the this video, okay, to show you how it works. Wow, and then finally something happened with my communications. Hola, sí. Oh, bueno, eh, siento, bueno, parece que no, que tengo algún tipo de problema de problema con la reproducción del vídeo. Bueno, en cualquier caso, en la presentación tenéis el link y os animo a que veáis cómo este dispositivo aplica todos los conceptos. Oh, sorry. All this device is able to apply all the concepts that we have reviewed today. Okay, and trying to prevent the wildfire in the boots. Okay, Well, thank you very much for your attention. Bye bye.